Talk a little bit about a couple big features in the world here. We'll talk about how they were formed and kind of how they work. So first one we're gonna go to, we're gonna fly out to Hawaii. Doesn't that sound nice? To Mauna Loa. Um, Mauna. Ooh, I think I spelled Mauna. Maunal. Hawaii. Okay. Let's fly out to the middle of the Pacific Ocean to see this lovely island chain here. And we're going to zoom way in, which we don't really need to, so we're going to zoom way out here. Now this, we're looking right now at the crater of Mauna Loa. And Mauna Loa has been erupting. It's a volcano. It's a shield volcano. It's been erupting since, I want to say 83-ish, continuously, which is pretty impressive for a volcano just to keep on pumping, pumping, pumping. I know a couple of years ago it was all over the news that the volcano was, like, lava was going into residential areas. And that was very scary. And that basically shows you, Mother Nature's still in control there, and that's what happens if you want to move onto a volcano. Um, and the Hawaiian Islands it's a hot spot. And what happens is the Pacific Plate moves over that hot spot, and these new islands pop up because of it. And we can see it's still happening today because there's the Big Island, and look, this is all Hawaii. These are all Hawaiian islands here, and it just keeps on as the plate moves. New islands are forming. There's new islands forming right now, right at this second. So it's pretty impressive to look at. Now we're going to look at Mauna Loa and the Big Island itself. There, it's the biggest shield volcano in the world. It's massive, and the shield volcano, pretty much, it's not the basic volcano that you think of. You hear volcano, we're thinking more composite stratovolcanoes, mountains that just erupt huge plumes of smoke, lava, rock flying everywhere, crushing everything in its sight. And that's not the nature of shield volcanoes. Shield volcanoes they're gently sloped. It's not an abrupt mountain. They can get very tall, like the Big Island here on Mauna Loa, but it's not like straight up. It's very gradual. Yeah, very gradual, and there's a lot of vents around the islands here. So a lot of vents, especially along the coasts, where lava will actually flow out and build up new coastline. And the magma is actually it's very viscous, so it can spread out very easily. A lot of those composite volcanoes, the volcanoes, or excuse me, the lava is very kind of hard and more like molasses, and it's hard. It doesn't really move a lot. The lava here kind of spreads out. It's very watery, so it'll spread out very easily, and that's how it builds up so much land. That's why the islands are so big, is due to that spreading nature of the lava there. So yeah, it's pretty cool. It's actually the tallest mountain in the world, though that most of it, not most of it, the overwhelming majority of it is underwater. It's taller than Everest, because it just builds off of the sea floor, and then this is just the peak. This is the peak, isn't it crazy to think about that? That is just the peak. It's nuts. All right. Now I mentioned our next place we're going, Mount Everest. So Everest. So let's fly out. All right, we're gonna zoom way in here, and I'm gonna zoom way out again. There, there she is. Just a beast of a mountain. 30,000 feet tall. It rounds up to 30,000. In reality, it's like 29,000 feet. It's massive. It's at the same height that airplanes fly at, commercial jets. It's ridiculous how tall this mountain is. And the reason it's so tall is because it's part of a continental conversion here of the Indian plate here and the Eurasian plate crashing into each other. And because it's two continental plates crashing into each other, they're both buoyant, and no plate is going to subduct. So what will happen is they'll crash into each other, and instead of going down, it'll go up. It'll rise up. And that's why we see the Himalayan chain here. Himalayan chain is the newest or youngest, whatever you would like, mountain chain in the world. Right around 40,000, or 40,000, no, that's brand new. 40 million years old. or the Himalayas. So it's the newest addition to the world here. The tallest mountains in the world, most impressive, that's for sure. Um, just ridiculously tall mountains, and that's just due to the fact, like I was saying, two continental plates crashing into each other, and there's nowhere to go but up. They can't go down because they're too buoyant. Like if you had a continental oceanic um, conversion, that oceanic is always going to go down because it's an older plate and it's denser, and it'll go down and subduct underneath the continental plate there. And a lot of times, you get when this happens is you get some volcanoes that'll form. About 100 miles inland from that continental plate because the oceanic plate will subduct and then it'll get turned back into magma when it hits the mantle, and then the plumes will shoot up and you'll get some volcanoes. Now our next place that we'll go to is a huge volcano. It's a super volcano. We're gonna go to Yellowstone, which is in our lovely country. So we'll fly over to Yellowstone National Park. Again, we're going to zoom way in. Actually, no, that's not too bad. All right, still zoom out here. The one thing that you kind of notice from the bird's eye view here of Yellowstone is how dramatic the landscape is. I mean, you got mountains, you got some nice farmland here, some flat land, a lot of mountains, a lot of rivers, some lakes here. It's a very dramatic landscape, and that's due to the fact because it's a hotspot, kind of like Hawaii is. And that hotspot is going to stay in the same area, and then the plate, the North American plate in this instance, is going to move over that hotspot. And as you can see here, it's kind of changed the landscape here. And a really cool thing you can see here is a lot of this green here is farmland. And that's due to the fact because a lot of magma and pyroclastic material and all this new material that the Earth is shooting up is very, very fertile. So you can see that farmers have been taking advantage of this, of that fact there, and kind of capitalizing on the natural environment there, which is great. Using what you got here, but Yellowstone, massive, massive hotspot. It's one of the biggest volcanoes in the world. There is very dormant. It's not going to go off anytime soon. Yeah, millions and millions of years it'll go off again, and when it'll go off, it'll be a problem. We'll just say that it'll be a proper problem, but we don't really have to worry about that there. There's a lot of trying to think of the heating from the Earth's core there, of geothermal heating that goes around Yellowstone, just because it's a very geological active spot in the world there, so a lot of people can capitalize on the free energy that's kind of given off by the Earth there. It brings to mind, I'm from South Bend, and the campus of Notre Dame University, they have some geothermal operations that they're trying to build right now. So it's kind of cool that the world is starting to switch over to more green forms of energy by just tapping into the Earth and using it to warm and heat things and as a way to generate energy there. So that's been my little tour of the world there of some notable features, and yeah, take care.